Hello everyone, welcome back to Advent of Code 2024. We can go straight into day 10 today. Nothing much to say about yesterday's solution, or no relevant changes to it. I could say some things about how long and gross it was, but it was a fun algorithmic challenge, and struggling with actually implementing it in Haskell was worth it. I don't know. Anyway, day 10. Hoof it. You all arrive at Lava Production Facility. Oh, they did that last year, wasn't it? Yeah, 2023 day 15, lava production. On a floating island in the sky. As the others begin to search the massive industrial complex, you feel a small nose boop your leg and look down to discover a reindeer wearing a hard hat. The reindeer is holding a book titled Lava Island Hiking Guide. However, when you open the book, you discover that most of it seems to have been scorched by lava. As you're about to ask how you can help, the reindeer brings you a blank topographic map of the surrounding tree, your puzzle input, and looks up at you excitedly. This reindeer has a lot of initiative, I guess I would say. Perhaps you can help fill in the missing hiking trails? The topographic map indicates the height at each position using a scale from lowest to highest. Based on unscorched scraps of the book, you determine that a good hiking trail is as long as possible and has an even, gradual uphill slope. For all practical purposes, that means that a hiking trail is any path that starts at 0, ends at 9, and increases by a height of exactly 1 at each step. Never diagonal, only orthogonal. Okay. You look up from the map and notice the reindeer has helpfully begun to construct a small pile of pencils, markers, rulers, compasses, stickers, and other equipment you might need to update the map with hiking trails. A trailhead is any position that starts one or more hiking trails. Here, these positions will always have height 0. Okay. Assembling some fragments of pages, you establish that the trailhead's score is the number of 9 height positions reachable from that trailhead via a hiking trail. In the above example, the single trailhead in the top left corner has a score of 1 because it can reach a single 9. 0, 1. So you can get there in a few ways. You have to get from the 0 to this 4 in one of 2 ways, and the 4 to one of these 8s in several ways, I guess. No, there's more than 2 ways. There's like 4 ways to get here and 4 ways to get here, I think. Yeah, 4. So there are technically 16 hiking trails here, but only 1 trailhead and 1 summit. So this example input is intentionally hinting at you that maybe a naive graph search will have too much wasted effort on visiting the same node multiple times. This trailhead has a score of 2. Yeah, fine, I understand. Sure. Score of 4. You can get to either of these, this, or this. Fine. I understand what a trailhead is. What is the sum of the scores of all trailheads on your map? So I believe this is there's always in Advent of Code multiple opportunities, I think, to make you, not like this is something that Eric does intentionally, but just like, a property of, okay. So the technique that I think we will be using today is called tying the knot. That's the interesting technique anyway. The rest will be relatively boring. And it's a cool thing that is mostly unique to Haskell because not really any other mainstream languages are lazy enough to do it. that simplifies this kind of self-recursive data structure in a way that I'm not going to have to worry about exploring duplicate nodes at all. We'll build a self-referential array, which is a grid, which will be, mapping the input array to, for each cell, how many 9s are reachable from it. In that way, we can make sure. So this is kind of like, this is dynamic programming, but done automatically by the compiler. I mean, it's also kind of not the compiler, it's the runtime system, really. You could argue whether it's like, oh, it's dynamic programming, is it memoization? What's the difference between those two? I'm not going to get into that today. But the idea is, we will take. You can see my mouse cursor, right? Yeah. Okay. We'll take this map, this array, and we will map a function over it. That function will refer, obviously, to the initial, to the map. Well, the map is a weird word because this will be an array, but it represents a map, i.e. like a topographical map. So it will refer to the cell it's on and its neighbors, but not... well, yeah, I mean, I guess... It'll have to refer to its neighbors both in the input map and also in the output map. And that's the trick, is that the output array will have, the cell here will contain a reference to the cell here and the cell here and the cell here and the cell here. But the cell here will also contain a reference to the cell here. So what do you, how does that get resolved? And the answer is with Haskell's thunks. Actually, I think we won't actually need any circularity because you can only go one direction along a link, but in principle it would be okay if there were circularity because the runtime system will ensure that each node is evaluated only once, and how the ordering in which it does that stuff doesn't matter to us. It will find its own way. When it gets to this 7, it'll end up saying, or I guess which direction are we going? Yeah, if we want to evaluate this 7, it'll say, well, I don't need to look to the right of me because that's lower. I don't need to look above me because that's impassable. I don't need to look to the left of me because it's 6, it's lower. I do need to look down to this 8. And this 8 will say, oh, nobody's evaluated me yet. I don't need to check left or right or up because those are all impassable from here. But I do need to look down. And then it'll look at the 9, and the 9 will say, I don't need to look at anything. My value is just 1. There is 1 9 reachable from here. And that's our base case. The runtime system will find it automatically for us, provided we build the array with care. So that's the overall plan for today. We won't need any mutation. We'll be using an immutable array of these self-referential values. Okay, so first things first, actually super first things, is that I didn't get my input file yet. Okay, so out of curiosity, it is 54 by 54. Okay, I don't think that matters. What I want to do first is go back to day 8 and grab this stupid labeling function. Or do I even need to? I mean, I do, right? Yeah, because I want to know... Yeah. I need to know the width and the height in order to start building the array. And then once I have the width and height, it'll be convenient anyway to have the coordinates of each point as well. So let's just grab this. We've done it enough times this year. I think, is linear not in my Cabal file? It's not. Well, if it's going to be something I use regularly, I should maybe add it to the template. Obviously, just depending on a big pile of random garbage that you might or might not use, is maybe not the best practice for a production application, but good news, that's not what we're building, so. I think, honestly, isn't the v2 type like pretty much all we need? Yeah, that's all we needed on day 8, so. You know, let's grab some other imports from here. What else did I need? Oh, this wasn't a version that used arrays, huh? Okay, interesting. So let's import data array, type array, the constructors being, I need array. And how do you in data array, yeah. Give me the version in data array, please. So this is what we'll be using to build our array. What do we have for mapping it? Index map. I kind of hate you for. I don't want fmap. I want like transform with index. Which I guess we don't have, huh? Okay, well, we'll just build a new array, which will be constructed. You know what okay, here's how I can avoid making dumb imports, is I can just say import qualify data array as a. There you go. Now there'll be useful imports. So my prepare function then, well, okay, what's the main type we'll want to work with? Just an array, a two-dimensional array of int, right? So we'll need import, actually let's put it up here. Data char is digit and digit to int. Actually, yeah, I don't, yeah, sure. Is digit is fine, I guess. I'll only need it to like be allowed to throw a better error if the map is broken, but that's fine. Actually, what does digit to int do if it gets a non-integer? Digit to int. It says it fails, but like, does it print something useful? It does. I'm looking at the source here. It just says not a digit, blah. That's actually a better error message than the one I would give. So let's not do the check. Let's not check. How about that? So I think our input type should be an array of v2. I mean, I can have a pair of int. Like, you know, a v2 of v2 of int, which ends up writing fewer things. Is that like... No, hang on. I just want a v2 int. Right? No. Yes? Because it's indexed. Yeah, I don't know why I would think I want... Right. The bounds... What actually is the arguments of the array function? It takes a pair. Okay, so you can't give it a v2 of v2. You have to give it a pair of v2. Fine. So it'll be indexed by v2s of int, and it will contain type height. Are these called heights? Elevations? they're called heights. Fine. The height is an int. We have an array of int to height. So our prepare function then is prepare of prepare is go composed with label grid, where go of bounds, which I think I'm ignoring. No, of course, I'm passing those to make array. Bounds and heights equals a array of bounds and yes. Array takes a list of associations. Bounds of can I just map fmap digit to int? Map fmap digit to int over heights. What do you think about that? Array is not in my Cabal file either, huh? We have to exit GHCI to get the new dependencies in. Okay. So that succeeds. And if I said prepare of the string 1, 2, 3, new line, 4, 5, 6, new line. That's an M, not an N? You can't trick me? What? Oh. Right. I'm not reading a file, I'm just calling prepare on a string. Okay. So it's a v2 from 1, 1 to 2, 3, where 2 is our y coordinate going down, or going vertically down as y increases. So it's 2 tall and 3 wide. At the top left is a 1. Top middle is a 2. Yes, perfect. This is exactly what I wanted. So now we just need the map function, which I think actually is very easy. This array is boxed, right? I assume, like the array type. Immutable, non-strict, i.e. boxed arrays. Perfect. Okay. So part 1 of array is sum of map score of a elms dot elms and compose that with the function that's going to actually do the work. 9's reachable from, like trails from. where the score of we will actually need access to both the original map and the input map, won't we? Now, I could put the... The problem is, I'm computing how many 9s are reachable from every point, and then just making that the value of the array. And we only want to score the ones that originally had a 0 there, right? The trailheads. So we can either make an array that contains the original value. I mean, it just like seems stupid. So I think I can just say a.assocs instead, get the index and the value, and then use the index to look up in the original array. Score of pos summits. That's a good one. Number of summits. Where it's going to be R a lookup pos equals 0 equals summits, and otherwise equals 0. So if in the original map this position had a 0 in it, i.e. if you look up the position in the original map, you get a 0, then we count the number of summits reachable from there. Otherwise, we simply count as 0. And we also need trails from, I guess, trails from the array. Trails from, I think the array is already in scope. Summit counts? I don't know. Summit counts is an array constructing a new array using the bounds, it's called, right? Yes, the bounds of the original array, and do we will let pos and height come from we'll just name this bounds and say where bounds equals this. It doesn't. Okay. There you go. No, come on. You know, I don't know why it's not. Oh, I don't want another where. That's why. Pos height comes from the assocs of the original array. And we'll say pos prime comes from the list. And I mean, I kind of actually we can use something from linear here, right? Although it kind of sucks. Pos prime comes, I don't know, dir comes from identity and negate apt to the bases, what is that called in linear dot? Okay, let's just look up linear. Linear dot vector probably. Oh, I should be able to look up basis. It's in linear vector. Yes, that's what I want. So it should know what I want the base. It should know I want the basis for v2 of int, right? Okay, what? Yeah, so that's x and y. And then I'll negate each of them. Actually, it's easier to just say pos prime will be pos plus f mapped over that. So we'll go either up or down in either the x or y direction and add that to the original position. And then it should be the sum. No, I've already screwed this up. Well, not in a huge way. But here I should say sum of do. And you could write this in a way that's a little bit less janky, but this is fine. So choose a position. Guard that in range bounds pos prime, right? What order is in range? In range. Of course, it's not in this module. Oh, I'm in the wrong file anyway. You guys can't see. I'm busy. Busy struggling. In range takes the bounds and then the index. Okay, great. Guard that the new index is in range. Guard furthermore that that the original array's mapping for pos prime is equal to height plus 1. In that case, return summit counts. The entry in summit counts at the position in question. So we choose a new position. We confirm that it's in range and that it's going upward by exactly 1. Part 2 has got to be, oh, actually it's okay to be like increasing by 1 or by 0 or something like that, right? Or it's like it's okay to increase by 2. So I don't know. We'll have to add a new parameter to the part 1 function or something, and then reuse that in part 2. But I think this makes sense. What does the compiler think of this? Okay, it thinks I should write another stupid report. That's true. I actually normally, so this kind of idiom of writing some function f mapped over some value apt to some other value is for taking a pure function of two arguments and mapping it over like the Cartesian product of two other things, or in non-list monads it could do something else. But here we actually want to parse it differently. We want to app these two things together first, yielding a list of vectors, and then map pos over that list. Of course, it should be pos and sum of this do. What is this a new error telling me? Are there a lot? There's just one. You expected a list of pairs of V2 and E. I agree, that's what you should have expected. At least in some context, I think this one. You got a pair of V2 int and V2 int of E, so that certainly is wrong. Why have you achieved this? Oh, there needs to be a pure here, I think? Yes. Because we're returning this into the outer do loop. Okay, now we're getting a more substantial error, maybe? You determined that I want an array of unit, huh? Well, that's not what I want. Why would you want that? Oh, because I said I'm returning a unit. How about if I returned an int? Okay, looks good. 0, probably not what I wanted. Okay, well, let's try a simpler one. Part 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Part 1, of course, of prepare of this. 0. Okay, well, I think we can all agree that this should succeed. So prepare of that, yeah, I mean, it is the normal thing. It's what we expected. So something is wrong in part 1. God knows what. Oh, hang on. I don't have the base case in for 9. It just eventually gets to the edge of the grid and says, nope, I give up. So what we need to do is say case height of is this actually a case for if? You don't write a lot of ifs in Haskell. I think it makes sense though. If height is 9, then 1, else all of this. Pure 1. Well, I guess if we're calling pure in both cases, we can lift that, I guess. Pure of if height is 1. Okay. course, I have to list the position. Pure of pause and there we go. Now I don't have to put it here or here, which is nice. So this looks a little bit like an fmap, right? Where I'm just saying map a function into... I mean, I guess it is. I want to fmap a function over height, but I need access to pause at the same time, so I don't know, whatever, I'm sure there was a fancier way to write that. Bounds? What do you mean? Oh, I still need the closing parent. It's just associated with this instead of with this. Great. Well, actually... One! Great. And to get anything else, I would have to write... Oh, I mean, I guess we should be careful. 1, 2, 3, 4, 5, 6, 7, 8. I'm not saying the right numbers, but... So now there should be a lot of ways, right? Like about 10? Problem. Oh, I didn't... There we go. Yeah, 10. May. 1326. Wrong. Okay. It's too high. So let's maybe look at this simpler input they've given. Actually, they haven't given what the right answer for this is, right? But like, here's a test input we could use. But wait. No, this isn't right. I just have the wrong algorithm. I think. Yeah, I'm still double counting stuff. Where's an example? That would show that. It would need like 2 ways to get 1, 2. Well, even this should demonstrate the problem. I'm counting 0 to 1 to 2. I'm counting you could go this way, and you could also go this way. The problem is that's not what I should do. This 0 shouldn't be... We shouldn't compute the sum of all the reachable things, but rather the max plus 1? That's not true either, I don't think. We need to know, like, whether these two are going to the same trailhead or to different ones. Like, if this one led to a 9 over here, and this one led to a 9 down here, we should add them together. But since they both lead to the same 9, we should only count them once. Only count one of them. So we don't care about the number of ways to get to a 9, which is what I'm computing. We care about the number of 9s you can get to. Okay. So we could, instead of putting a number in the array, we could put a set of coordinates into it. These are the 9s you can get to from here. And then union together all of the sets that your neighbors produce. Your reachable neighbors, anyway. Yeah, that ought to do it. Okay, I just sort of misunderstood or got too eager with... Like, I understood what a trailhead was, but you saw, as I was doing this, like, test, I was like, yes, 10, that's right, even though obviously it's 1. So, like, I didn't really understand what it was. I was using some incorrect mental shortcut there. But it's fine. We have to change very few functions here. Then singleton pause, where we have to import data set. So that's one thing. Otherwise, it's m concat of do, right? Is that it? Do you get the size of a set or the length of a set or what? Do I have, okay. Data set. Size? Yeah, size of a set. Okay. So if the position is 0, we want the size of reachable summits. Okay, we shouldn't call them summit counts. This variable should be renamed. But before I do that, let's see if it's even right. Now we get 2, which is correct because there are 2 9s. And if I went even one step further and just wrote this again, there should be 4, right? Because each 0 could get to the 9 in 2 different ways. Or it could get to each 9 in 2 different ways? Is that true? Yeah, because the middle row is going up in elevation by 1. So you could go right at any, or up at any point from the bottom, but only once. Or no, wait. This doesn't work. Does it? Why not? Yeah, because there are now 3 9s, but the top one can only access 2 of them. The one on the top row and the middle row. And the bottom one can access 2 of them, the middle row and the bottom row. So it should be 4. It is. Okay. 709. And if this is the correct answer, then we'll go rename that variable. Okay. Slight hiccup there, but we're fine. Summings? Who knows what my fingers were up to there? Okay, so that, I assume, still works. It does. Day 10, part 1. Let's see what part 2 is all about. The reindeer spends a few minutes reviewing your hiking trail map before realizing something, disappearing for a few minutes, and finally returning with yet another slightly charred piece of paper. Ah! This is what I had before. A paper describes a second way to measure a trailhead called its rating. Yes, the number of distinct hiking trails which begin there. Okay. So we need to parameterize this by a monoid, I guess. And a function that, given a position, tells you the... Yeah, sure. Let's do that. That'll be interesting. Well, yeah. Solve, I guess, provided that... I don't even... Do I need a monoid? Yeah, because I need empty. Okay. Monoid M and a function from v2 int 2m. Then it produces for you a function from input to m, I think. Solve base, the base case, of all this. So sum.map score is no longer correct. It should be... Well, let's first go find the places I should call f and mempty and so on. So here it should be mempty... Here it should just be summits. Height is 0, then instead of singleton, it's f. And mconcat is already right. Great. Okay. That makes sense. That makes sense. So then sum and compose with map should just be fold map score. Where fold map is the function here. I mean, it probably will tell you the type, right? Nope. We have to import it or something? I don't know. Anyway, I think it's in base these days. It takes a foldable of A, which in our case will be a list, and a function from A to M, where M has to be some monoid. Oh, but I don't need the score function. Yes, I do still need the score function. Oh... I guess... Yeah, so it returns an M. And I guess we'll have to, in part 1 and part 2, do the getting out from M into, like, the specific type we're looking for. The int we're looking for. I could make that another parameter to solve, but it doesn't really need to be. So fold map score. Oh, but that's not right. That's not right at all. Because I don't just want to combine the list of all the trailheads, or the set of all the trailheads, or summits. I need like a list of the sets of summits reachable by various positions. So I think I actually do need score to be a function here. Is fold sum.map. This can't actually be score because we're not going to make the caller deal with the position. We're just going to give them the list of summits. Map score summits, I guess. Or score summit is score of summits. So this is then, I guess, a function from m to int, producing an int as a result. Okay. I think that makes sense. So part one is solve. We're going to compose something with solve in a minute, but what's the base? The base is S singleton. We'll take the position and make it a singleton. Score is S size. And then we'll compose that with nothing, right? Because we're actually just returning an int. Okay, so does this look good at all? Do you think? I didn't type an arrow somewhere that I had to. F is not called F; it's called base, which arguably should be called summit, the opposite of base. Couldn't deduce monoid. Oh, of course. Right, I knew I had to compose something in there. Wait. No. What do you mean? This mempty should be 0. So why exactly do I require a monoid? Why can't I have a semigroup? I'm never using mempty. It's because this do might return an empty list, and I need to know what to use there, and it should be the empty set or 0. Okay. 709. Was that the answer? It was. Okay, so that's good. Now we can recover what we had for our earlier part 1, the broken one, by just passing in the right variables here. Solve of, well, it's get sum composed with, let me go import data monoid sum. Solve. Actually, I mean, 0. Oh, I don't need get sum, do I? Solve always returns an int. So I don't have to compose with get sum. I have to pass get sum here so that it knows how to turn the score at a summit, which will be a sum of int, into a number, which is just extract the number. Yes, right. This has to be a function. And also 0 was the wrong answer anyway. It should have been const 1. So ignore the position completely and return 1. There's 1, 9 reachable from this summit. There's one way to get to a 9 from here, which is to not go anywhere. 1326, the wrong answer that we got earlier, which is now right for part 2. Great. So let's commit this, and then we have a little bit of talking to do, I think. So when you have some chunk of code, a function or a value or whatever, that you need to be more general about, you want to reuse it somehow, typically. You want to reuse it, but like make some changes in one or two places, and so you turn it into a function. I mean, you know, in a non-functional language, you might do something else, but in a functional language, typically what you do is you turn that code into a function, and you give that function parameters for all the places you want to change the result. You can also, as we've done here, although it's perhaps less common, I don't know, maybe it's more common if you're a better theorist than I am. But you can parameterize by a type as well. You know, if I wrote a function that works for lists of strings, and then I later realize, actually, I have a way I'd like it to work for a list of anything, you could just replace string by a in the type signature, as long as you don't deal directly with any string functions. But what if you do use the strings a little bit? You only ever use them, like you only concat them, right? Then you can say, well, I could use a type. I could parameterize it by a type, but the type can't be just anything. It has to be a type where the concept of concating makes sense. And there are type classes in Haskell for many such concepts. Monoid is one of them, and it's, you know, we've talked about monoids a little bit before in this series. You know, it's broadly speaking the set of, you know, it's a type which has some elements, like, you know, there are values. A monoid is, okay, in Haskell it's a type class. In kind of set theory, it's a set, right? A monoid is, well, it's a triple, I guess. A monoid is three things: a set of elements that are valid values of the monoid, an empty element that you can combine with any other element and have no effect, and a combining function that you can apply to any two elements and get out another element. Provided that that combining function is associative, i.e. that you know, A, B, C has to be the same as... I'm so bad at associativity. How does this work? I think it's A, B, C? Yeah, those are... Provided that those are the same, and this operation has an identity element, then your set is a monoid, and you can apply all of these monoid... There's zillions of functions that do cool things with monoids, and we didn't use very many of them here. You'll see we don't even have mempty once. But because we used mconcat, we're kind of implicitly using mempty, saying add up all of these elements using the combination operation of the monoid. And if there are no elements, you have to use the empty element of the monoid. It's kind of funny that, like, really this is the only thing in here that makes use of the fact that the type we're given is a monoid. Mconcat. So I guess, like, in principle, you could, instead of requiring monoid, you could require a way to turn a list of M in, a list of whatever into a list of M into an M. But monoid already has that plus more. And there are lots of built-in monoids for doing interesting things. So in part 1, we used the fact that a set is a monoid where the empty element is the empty set, and combining two elements is unioning the sets. We can go look. There's a type called sum in data monoid, data semigroup apparently, actually. Which is just a new type wrapper around a number of some kind. But the type specifies that the identity, so the monoid instance specifies that the empty element is 0 and that the combination operator is plus. So you add up the things at the various directions you could go instead of uniquing them. And so, there's the reason that you don't just have a monoid instance for int is that there are actually two ways ints form a monoid. They can either be summed and the base element, what do they call it? Neutral element? Identity element be 0, or they can be multiplied and the identity element be 1. Those are both valid ways to make a monoid out of ints. So int isn't a monoid. You have to specify whether you want sum or product. So that's like the crash course on monoids and why it was useful here to parameterize by a type rather than by, in addition to by a couple of functions, right? These are the two things that we had to take as parameters, and I kind of wish we didn't have to do quite all of that. But I think it was the right way to go. Anyway, that's all for today. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.